Hi, ladies and gentlemen, this is Mr. Green, and this is another in my series of lessons for AP Statistics. Woohoo! We're getting so close to the end, it's ridiculous. We're in our last chapter, and just so that you all remember, there is no final in this semester. So we will be ending up on this with taking the unit test on this unit. Okay? This unit deals with probability. So what is probability? Well, as I told you last time, you can basically take, the number of times that something occurs the way you want it to, divided by the total number of outcomes, and that will tell you the probability of an event occurring. For example, the probability of the number 6 showing up when you roll one dice. Well, you would figure out how many sixes there are on the dice, one, out of the total number of possible outcomes. Well, there are 6 possible outcomes, 1 out of 6. That's the way you would write it. Really, the probability is not that big of a difficulty. You look at how many times it turns out to be what you want it to be out of how many possible outcomes there were. That's where you're going to get the probability from. So, some basic rules of probability. Rule 1, legitimate values. You can never have a probability less than 0 or a probability greater than 1. Probability will always be somewhere in between there. This is 100%, this is 0%. Rule 2, find the sample space. If this sample space here, okay? If you're doing the probability of the entire sample space, that's going to be 1. That's 100%. But find that sample space if you can, okay? Write down all the possible combinations. Make certain you have all the possible combinations written down. Sometimes that will help you. Then you can just count the number of correct ones as opposed to the number of possible ones. Okay? Moving forward. Rule 3, the complement. This one says that if the probability of an event is one thing, the probability of the event not occurring is going to be, when you add those two together, you're going to get 1. In other words, 1 minus the probability of an event will be the probability of an event not occurring. So, if the probability of an event is 20%, the probability of the event not occurring is 80%. So you can look at it and get two percentages there really, really very easy. Okay? So, experimental probability. Well, experimental probability is the relative frequency at which a chance experiment occurs. If you flip a fair coin, you would expect the probability to be 50%. You expect to get 50% heads and 50% tails. But if you happen to do it one time, you might get 17 over 30. That is an experimental probability. Okay? It doesn't mean that it is significantly different than the expected probability. It just is different, right? Well, statistics and normality tell us that that can occur very frequently. Okay. One thing that goes on here, the more times you flip the coin, the closer you're going to get to the theoretical probability as opposed to this experimental probability. That's that theory of large numbers again. Okay? Remember doing that? Okay. So let's go on to the rule number 4, multiplication. If two events, A and B, are independent of each other, they have no dependency on each other, you would say the probability of A and the probability of B, multiply the two probabilities together. In general, what you're saying is the probability of A and the probability of B is equal to the probability of A times the probability of B, given that A has already occurred. That's what this line means right here, given that. So the probability of B given that A has already occurred. Okay? That's what you would do if they are completely independent consequences. Like what? Well, I roll a dice. I get a 3. Okay, well, I had a 1 out of 6 probability. I roll a dice again, and I'm looking to get another 3. That would be a 1 out of 6 probability. I can multiply those two things together and get a 1 out of 9 possibility. Right? 1 out of 3, or 1 out of 6 times 1 out of 6, 1 out of 36 possibility. I can't multiply in my head, especially when I'm talking. But that's the way that this is done. That would be an example of an independent, not related upon each other at all, type of an event. Well, Mr. Green, what would be an example of a dependent operation? Well, if you took a deck of cards, you know that pulling a card out of a deck of cards has a probability. So what's the probability of pulling an ace out of a deck of regular cards? Well, there are four aces. There are 52 cards, so it'd be 4 out of 52 or 1 out of 13, right? Yeah, 1 out of 13 would be your probability for that. If you put the card back in, the probability of pulling another ace would be 1 out of 13. That would be an independent situation. But if I didn't put the card back in and left the card out, then I no longer have a 1 out of 13 chance. I've got a 3 out of 51 probability for that second one. That would be an example of a non-independent event. That would be dependent. It would be dependent upon the first event having occurred. Okay? See how one was dependent upon the other? Okay. Addition. If two events, E and F, are disjoint, not related in any way, shape, or form, you can just add their probabilities together. Two events, E and F, are not disjoint. You might want to add their probabilities together, but then you have to subtract where they overlap. Okay, now you got me confused, Mr. Green. What can we look at there? Well, look at this one. I've got a sample space of flipping a coin and rolling a dice at the same time. So I've got heads, and I could get a 1 through 6, or I could flip a coin and get tails and get a 1 through 6. Okay? So if I look at the entire sample space, that's what it looks like right there. Okay? So I'm being asked, flipping a coin, rolling a dice are independent events. Independence also implies the events are not disjoint, hence the overlap between the two of them. So if I were looking for tails or even numbers, well, there's all the tails. They're all in red. Oh, I'm not even. Tails and less than 3 is what I was looking for. All the ones that are tails are in red, right? So that would fit into this circle over here. Less than 3 would be these two and these two here. See, these two here. If I just counted those up, I would have 8 numbers there. But I don't want to count these twice, do I? No, I want to keep those out. So what we're going to do is we're going to figure out the number of tails. We're going to figure out the number of less than 3s. And then we're going to subtract off those that are tails and less than 3s, because we need to subtract that off once. So the tails, that was 1/2. I add to that 1/3 because there's only 2 out of 6. Okay, so that'd be 1/3 of the numbers there. And I'm going to subtract off 1/6 because there's only 2 out of the 12 possible things here. That'd be 1/6. This whole thing adds up to 2/3, or 66%, 67%. Okay, that's an example of what we're looking at, not disjoint. Hence, we've got an overlap between the two of them. Okay, rule 7. What's the probability of at least one occurring? The probability that at least one outcome happens is 1 minus the probability that no outcome happens. Okay? The example that I have for that one is, if you've got the probability that a pro golfer will make a hole-in-one is 1 out of 200. If I put 4 pro golfers together at a hole and try to figure out what's the probability of these 4 pro golfers making a hole-in-one, well, independent events, I would multiply them together. 1 out of 200 times 1 out of 200 times 1 out of 200 times 1 out of 200. Okay? But what's the probability of no one getting it? Well, it'd be 1 minus that, right? That would be the probability of at least one of them making it. Not very much. Okay? So you have to look at that type of an approach when you're looking at some problems, when you're looking at least one thing occurring. Okay? Conditional probability. This is a probability that takes into account a given condition. So the probability given that A has occurred. Probability of B given that A has occurred. What you're looking for here is the union of A and B on the top and the probability of A on the bottom. And that's what you're going to be doing. You're going to take the probability and divided by the probability of the given. Okay? That's what you're going to be looking at when you're looking at the probability of an event given that another event has occurred. Okay? So, having run through those rules, that's what you need for this particular unit, this particular lesson. If you need any other questions, feel free to come by Toga and ask questions. I look forward to it. I appreciate you guys telling me that you're in that you're in AP Statistics when you send me K-mails. It really helps. And I will talk to you next time.